So greetings of the day, students. Our next topic is elimination of unit production and normal forms. So first of all, definition of unit production. A unit production in a context-free grammar, capital G, is a production of the form of A goes to B, B goes to C, C goes to D, and so on. Means it is a production in which you are getting some sort of chain, right? So, or you can also say that unit productions are the productions in which one known terminal gives another known terminal, or you can say that a variable gives another variable. So here A is a variable, it is generating B, right? So B is generating C, C is generating D, so on. It is of the form of chain. So let's look at the method of how to eliminate unit production. So example 1. So in this example, eliminate unit productions from the given context-free grammar having the productions of the form of. So here you will be given with some productions. Here S goes to AB, A goes to small a, B goes to capital C slash small b, C goes to D, D goes to E, and E goes to A. So here, as you can see, the actual chain starts from B because B goes to capital C and C goes to capital D and D goes to E. So you have chain in these three productions only. That is production number 1, production number 2, and production number 3. Now you have to eliminate this chain. So step 1, you just need to write identification of chainable variables. So first of all, we will start from the starting variable and you will have to write that much amount of W's as equals to your variables. So first of all, you will have to write W for S because S goes to AB, but AB is not going somewhere else. S is not making chain with some other variables, right? I hope you understand. S goes to AB, but AB is not going to any other variable. That is why in a W of S, S will be the only variable. Similarly for W of A. Now A is terminating to small a. It is not generating another variable. That is the reason I have written capital A in W of A. Now let's proceed for W of B. As B is making chain with C, C is making chain of D, and D is making chain of E, right? So W of 0B, only B is there. W of 1 of B, B union C, B comma C is there. Then again C is making chain with D and D is making chain with E. So that is why finally in W of B you will have to write B comma C comma D comma E because the actual chain starts from the variable B and it ends to E. So that is the reason I have included B comma C comma D comma E. Next, similarly for W of C. So C is making chain with D and D is making chain with E. Similarly for D. D is making chain with E, but E is not making chain with any other variable. So that is the reason E is only included in W of E. Remember one thing, students, you will have to include that variable itself whether it is making chain or not. S is not making chain. That is the reason I have included only S. That is, you need to write the original variable. I hope you understand the step number 1. So let's proceed towards step number 2. So step number 2 says that you will have to generate new productions in G1. So G1 is a new grammar. So first of all, you need to write those productions whose answer is single. That is, S goes to AB, but AB is not taking to somewhere else, right? So that is the reason I have written S goes to AB. Number 1 production. Then you need to write terminal string productions. That is, A goes to small a. So A goes to small a. Next, E goes to small a. E goes to small a. Now let's proceed for the elimination of chain. Now you have the terminal that will eliminate E to small a. So put that value in this. You will get D goes to small a. If you get D goes to small a, you can similarly replace D's value in this and you will get C goes to small a and for ultimately B goes to small a. So I hope you understand the process. So here you will write C goes to small a, D goes to small a, and for B goes to small b is the original production, and for C goes to A. Here C will be eliminated by small a. I am repeating this step again. You will have to start with those productions whose answer is single. So S goes to AB, number 1 production, small a goes to A, E goes to A, and capital B goes to B. These are those productions whose answer is single, or these are those productions that are terminating into terminal strings, right? After that, start from the last part, that is E goes to A. In first step, E is making chain with D. So you can replace E with small a, right? Then D is making chain with C. So you can replace D with small a. Ultimately, it will eliminate the unit production. I hope you understand the process. So step 3 is optional. If in a question you will be asked to reduce grammar also, right? You will be asked to reduce grammar also. So as you all knows, the original starting production is S goes to AB. So only A and B is taking part for the derivation of the string. So you need to write A's and B's productions only, right? So capital C goes to A, capital D goes to A, and E goes to A. So these productions are useless productions, and finally you are left with only these 4 productions. So this is the concept of unit productions. Next we have very important concept, the 3 normal forms. So first normal form is KURODA normal form. Second one is Chomsky normal form, and the third one is Gray-Bach normal form. So let's get start with first normal form, which is called KURODA normal form. So definition, a grammar is in KURODA normal form if all production rules are of the form of these 4 productions only. Capital AB goes to CD, capital A goes to BC, A goes to B, A goes to A. If other than these productions you are getting any production other than these 4, they will not belong to KNF. Only these 4 productions are the part of KURODA normal form. That is, on left hand side minimum or maximum 2 variables will be there, or on right hand side maximum or minimum 2 variables will be there, or 1 variable on left hand side, 2 variable on the right hand side, 1 variable on left, 1 variable or right, 1 variable on left hand side, and only single terminal will be there on the right hand side. So where capital A, B, C, D are the non-terminals, or you can say that variables, and A is a terminal symbol. So this form is named after Saigi Yuki Kuroda. So he was the scientist who originally called it a linear bounded grammar. So originally this normal form is called linear bounded grammar. So every grammar in KURODA normal form is non-contracting and therefore generates context sensitive language. So let's proceed with its meaning, non-contracting. So here the first production capital AB goes to CD is replaced by context sensitive rules. So these are the rules. So here you can replace capital AB goes to AZ, AZ goes to WZ, WZ goes to WD, and WD goes to CD. It means this production is replaced with any of these 4 productions. So here as you can see, A and A is same. Similarly W and W is same. So here number 1 and number 3 are left context sensitive because here the left context is same, A or W or W. And in case of second and fourth production, the right context, that is Z over here, and D is same. So this technique also proves that every non-contracting grammar is a context sensitive. So thank you students. In next video, I will be sharing with you these two other normal forms, that is CNF and GNF. So thank you. If you have any doubts, feel free to ask me any question. Thank you very much.